Okay, so analysis takes place in the elaboration workflow. So next one, unified process. We develop analysis model because of which reason? So
这是我们的对吧？对，415，对，415是你这个随着那一什么的，06012331，错，对的。你process。
Right. Two is correct. So first, it's a required workflow is incorrect. You can skip it for simple systems. You can go directly from requirement to design. And we want to produce a stable, robust, and logical system structure is correct because remember analysis classes, they encapsulate and isolate changes, right? The boundary classes encapsulate the user interface, and entity classes encapsulate the database. So they have produced a stable, robust structure so that if you change your design later, your analysis model stays the same. So we may not have captured all of the system's requirements. So analysis model is based on the requirements document. So it's not responsible for any of the requirements missing. So implementation environment is not taken into account. It's taken into account in the design model, not in the analysis model. Analysis model is always implementation independent. You need to get the client's approval of the analysis model. That's not correct. Analysis model is internal. It's never shown to the client. Only the requirements document is shown to the client to get the client's approval. During system analysis, we focus on handling functional requirements only. So domain model is not. It's used in the system analysis for constructing the entity classes, but we are really focusing on the use cases and designing each use case as a collection of boundary, control, and entity classes. So non-functional requirements are not considered, like security, like performance, reliability. They are only addressed in the design stage. We divide the functionality of a use case into boundary, entity, and control classes. Because of what reason? 3 is correct. So now analysis classes handling functional requirements only. It can be divided into 3 stereotypes. Each one encapsulates and isolates changes in one part of the system. Boundary classes encapsulate changes in interface. Entity classes encapsulate information, that is database information. Control classes encapsulate control logic. So you draw this abstract icon here. It represents perhaps a very complex collection of design classes later, so that you can modify your design without modifying your analysis model. So that's why you say encapsulate and isolate changes. So they're the only kinds of classes available to us. That's not correct. Well, for the analysis model, we do have the 3, but you can also define others. In the class, we only introduce 3, but you are free to define other helper classes. So sequence diagrams use these classes. That's true, but that's not the reason for dividing the use case into these classes. That's just the observation. User can easily understand the system requirements. Again, analysis model is not even shown to the users. It's internal. So message passing is more easily described. That's not correct because classes, objects communicate via message passing. So any classes can pass messages. So it's not the reason for having the 3 types of classes. So it's not relevant to the question it's asking. So analysis model is scenario is what? Yes, instance of a use case. So scenario is execution of a use case instance. Helps identify user object interactions. So, for example, a student registering for a course is a use case. Perhaps then student Tom registers for Comp211 is a scenario. So the classes participate in the use case. That's not a scenario. That's part of a scenario. Meeting the developers, that's not even close. Passing a message between 2 objects. Well, a scenario involves passing of many messages, but it is not a passing of message. It includes passing of messages, but it's more than that. It's a collection of objects and messages together and performing a use case instance. So all the entity classes that participate in a use case, so it includes boundary, perhaps control, and other include in addition to entity classes. So it's an instance. We saw many classifier instance distinctions: class versus object. So operation versus method, and also use case versus scenario. So which of the following is not shown in a sequence diagram? So this question is tricky. This is very tricky. So 4 is not shown. Hold on. So sequence diagram shows the object rows involved. Therefore, these stuff, these here, these are object rows. First of all, you see this colon in front of the class name, it indicating it's an object. You can have an object name in front of it. Say Tom colon register says register named Tom, but you can omit the object name. But having a colon in front of it indicating it's an instance, it's an object. In addition, it's object rows involved. That is, an object plays a role so that one object can participate in multiple rows in multiple sequence diagrams. So the fundamental point is that these are not classifiers. These are instances. Even though you draw the icon representing the say entity class, it means that it's an instance of an entity class. So all the others are there. Any questions on that? So remember, colon represents instance.
But they are entity class, control class, boundary class. They cannot be regarded as class. They are rows.
They are object rows. That is, so they're not used here in the sense of a classifier. They're used here in the sense of a concrete runtime object, runtime instance. That is, we're talking about. So you're passing messages not between classifiers, but between the actual instantiated runtime objects. So the others are there. So messages are there, lifeline are there, combined fragment. That is this thing here, representing loops and alternatives and break. Yes. Represents what? Represents objects. So there are two types of interaction diagrams. One is the communication diagrams, which is not covered in this course. So sequence diagrams are covered. In both of these two diagrams, you are dealing with objects. Communication diagrams is a more intuitive thing. Like you can draw a box like a representing a object, another box, and you send messages. You label the messages with sequence numbers, say 1, 2, 3, 4. It represents exact same information as sequence diagrams, except it's drawn in a different way to emphasize the system topology of the object's distribution. While sequence diagrams more emphasize the timeline evolution of the message passing. So, yeah, these two really focus on instances. So a self-delegation, if you forgot where that is, it is this. So it means that it calls a method in itself. So let me see. Is there something on the notes? All right. So it means that the transaction coordinator calls the kill operation in its own internal in this same object.
Is there any diagram will involve a class inside?
Involving
classes. Just like the question you asked, what is not involved in the sequence diagram. So is there any diagram will involve a class in it?
Of course, class diagrams, domain model. Yes. You see the difference. Domain model is showing the classifier. Say you have, say, person, and student is a special person, professor is a special person. Well, here the emphasis is different. Sequence diagrams, you're not really cared about whether a student is a person or not. You're cared about the runtime object of a person, how it communicates with the professor and course and other objects. So they have really different emphasis. Yeah? Any questions? Any more? Yeah, okay. So,
wait a moment. I have a question about self-delegation. Do you mean just a self-circle kill checker is enough for a self-delegation?
The self arrow means that you're sending a message to yourself.
Is it just enough for self-delegation, or self-delegation should include kill asynchronous flow to another?
No, self means that you're calling yourself.
So, no, 就是下面的 kills 不用算进去的吧？
Oh, this is just okay. So this kill is this message to transaction checker. It's part of the as part of the invoked operation inside of the this method call. You are calling the kill of the other object. So self-delegation really refers to the self-sending of a message. Kill checker. I send a message to myself. That's self-delegation.
How about the actual here? Is this an object as well? An instance as well? It's not a class.
Yeah, it's an instance. It refers to a specific person. So yeah. So this is describing a scenario, right? So everything is concrete. You have a concrete person sitting there invoking a concrete object. The object sending messages to a concrete instance of another object.
Just like the.
Yeah.
And how about object destruction? This is because of Q that it killed the other system.
Object destruction, you can self-destruct. In C++, you can do delete self, right? In here, say this guy gets a kill command, and then it does delete self. So it just happens to be named a kill. Where you can say other word. It's not a keyword. So it's really just a message indicating that, okay, you should kill yourself now. Even if you don't have the message, that object can also kill itself automatically after it's done its work. Oh, exactly. After this, there's no more lifeline. After the cross, it's gone. Okay, so so in the sequence diagram, object creation is shown by, this is a simple question because I just showed you, so only 30 seconds. So a message sent directly to the new object. So 5 is correct. So object creation is shown like this, right? So you have an arrow pointing to the object box instead of pointing to a lifeline point.
Just no lifeline. It is direct to lifeline.
No, this is from down here is lifeline. From down here is lifeline. This box is not part of the lifeline. This box is the object.
But you see the B invalid arrow is directed to a lifeline, right?
Right, that's not object creation. Creation refers to this, new. Right? So it's asking object creation is shown by what? So message sent to the new object, sent from the creating object, not to the creating object. So on a state machine diagram, the state of an object can be characterized by I think I shouldn't turn off the sound, otherwise. So not the events, it's the links it has with other objects. So
links it has with other objects.
So state may be characterized by the value of one or more attributes of the class. The bank account can be in credit if the balance is greater than or equal to 0, overdrawn if not, and existence of a link. Say a professor can be teaching if there's a link to a session object. Otherwise, it's not teaching if there's no link from the professor object to the section object. So a state is characterized by either one of these. So it's not the operations. So state is characterized by its attributes or links. Right. So 3, the message it receives. That's not correct because the message it receives may drive the object to a particular state. So state may be determined by the messages, but it's not characterized by it. Characterized means that you call this object in a particular state because of the attributes or links. So the use cases it participates in, that's not correct, the events. So that's similar to 3. So really, it may be determined. There's maybe an infinite variety of different input event sequences that drive the object to the same state. So, right, if you do a deposit, if you deposit 1,000,000 times, each one depositing $1, then after all these events, you're always in the same state, imbalance. But it's not characterized by the events. So event on a state machine diagram can represent so the 4 is correct. See, no one chose 4. So let me see. So events can be a call event, a receipt of a synchronous call, change event when the specific Boolean condition becoming true, a time event after some time, or when some time, elapsed time, relative time, or absolute time, and signal event. That's asynchronous communication. So, what am I doing? So here, completion of an activity, that is not an event. You may be confusing it with automatic transition, right? There are 2 types of state transitions. Automatic transition is taken when the particular activity in the state is finished and the transition has no guards, no event triggers. And non-automatic transition, event trigger transition, is taken only when the event arrives. So that A is obviously not representing an event. A completion of an activity may trigger a transition, an automatic transition, but it's not an event. So event triggers transitions also, and completion of activity may trigger transitions also. So, but it's not an event. So return from message sent. No one chose this. So exiting a state. So it may trigger exiting a state, but doesn't represent exiting a state, right? So the passage of a period of time, so that's the time event. That's correct. The guard becoming true, this is not correct. Again, this is the distinction between the change event and a guard. Look at this guy. It's a change event. You may have another type of transitions as event square bracket b less than 0, balance less than 0. So balance less than 0 is used here as a guard, representing a passive guard, and another active event happens, you check the guard. If the guard is false, you don't do the transition. If the guard is true, you do the transition. But here it's an active change event. Means that when the balance goes below 0 from above 0, this particular event is triggered. You have the when round parentheses. So it's like an active database. Whenever you say something updates the balance, I don't care what. For this style of specification, guard style, you may say withdraw, and then have a guard balance less than 0, and then if it's less than 0, you can do something. You can freeze the account. But when you say when balance less than 0, it means that I don't care if you're doing withdrawal, you're doing check cashing, or if you're doing some other, you buy some stocks, anything, I don't care. As long as the balance goes below 0, just trigger this event, right? So, that's the time event, right? When, that's absolute time, or after, that's the relative time. So you can say something is triggered after 10 minutes, right?
That can also be another type
Of course, it says can represent. Doesn't mean always represents, right? So it's just one type of event. So, yeah. So it's necessary to go through the system design workflow because, oh, right, did I do this already? No, yeah. Right, 2 is correct. So your system design adapts the analysis model logical structure to the implementation environment. So you gradually build a skeleton and grow the system. There's 2 steps. Skeleton is the architecture, and grow the system. So implementation environment is the technical and management constraints. So what hardware software will the system run on? Programming language used, existing software to use, like the DBMS, to use relational database or object-oriented database, user interface management system, to use Microsoft or Java user interface, etc. What development people, organizations will be involved? That is the software distributed? That is, you may have to run it on different sites in the US and in Hong Kong, or is decentralized. So it's not a part of the unified process. That's correct, but unified process is a template. You can customize it to your own organization and to your own project. It's not a set of iron rules. So just because it's part of the unified process doesn't mean that you have to do it. So we need to adapt besides, there are many other processes. A project can take a agile or waterfall or some other. You don't have to use the unified process. So you need to, right, analysis model does not contain all the requirements. Of course, it really focuses on the functional requirements, on how the use cases will be realized. But the requirements are contained in the requirements document. It's too formal to implement. It's too informal to implement, really, because you're using natural language. You don't have concrete units for any of the numbers. Say something money, you just say money. You don't say stubble or floating point or integer. That's too informal. Haven't include the user interface in the analysis model. it shouldn't be in an analysis model. Analysis model focuses on the functional requirements. User interface is just represented as a boundary class. You just draw the boundary class, and you leave it there. You design the user interface later, not in the analysis model. Which of the following is not a major issue to consider in the design model? Okay, 2 is not a major issue. All the others are. So hardware software will the system run on. This includes system software, which means operating system. Hardware, which means that are you developing a system for a powerful workstation or for a small PDA? That's the hardware limitations. Distribution, is your software distributed or centralized? So languages, existing software. That is, when you're developing a system, you don't develop everything from scratch. For your projects, you're using Microsoft Access as a database, right? So that's third-party existing software you're using. So you must choose one in your design model.
So what is the user characteristics?
This is because the design model is used within the software projects, within the software developers to implement the use cases, right? So therefore, all this is invisible to the users. All the design classes are invisible. So it's not concerned with the UI design. So it doesn't consider characteristics of the users. It's purely technical for the developers to
What do you mean by characteristics?
It means that is the user a technically savvy? Is he perhaps a manager? What's the user? Is it a grandma, or is it right? What kind of user is it? So all the others, people and organizations involved in the development, it's also a major issue. So team competencies. And also development, is it distributed or not? Besides the software may be distributed or not, you may have a distributed development team, right? Maybe one team in the US, another team in India. Programming languages, right, these are part of the issue. So the active class is one in which right, so has its own thread of control. it's shown with a thick border in the class diagram as a tradition. So it can be identified by performance, throughput, and other requirements. So if you have fast response requirement, you may need to dedicate an active object for taking input and providing output. Because it has own thread of control, it doesn't have to wait for other objects. And you give it a high priority, it can take input anytime. So system distribution onto nodes, then you have one active object per node and separate active objects to handle internal communication. That is, you may have active object on the node for handling the business logic, and you may dedicate a helper active object for handling communication on the node to ensure responsiveness, so that the communication is not delayed by the business logic processing, because you have separate active objects. Remember, if you have a single thread of control, then it's sequential, right? But one thing must wait for the another to finish. But if you have multiple threads of control with multiple active objects, then they can be concurrent, they can be interleaved, so response performance is improved. And also active object for initiate and monitor activities for startup and termination, liveness, deadlock avoidance. You will dedicate an active object for monitoring, perhaps sending heartbeat messages to everyone and collecting responses back. If something doesn't send back a message after a while, then perhaps it declares it to be dead. So that's the uses of active objects. So someone chose tool for which activity diagram is required. Activity diagram may be used for any class, not just active class. It's used for activity diagrams. If you recall, it's used for two purposes. One is for describing the high-level workflow behavior of the entire system spanning many objects. One is describing the internal implementation of an operation, which is used later for drawing the flow graph and doing the business path testing. So it has nothing to do with active class. Deployment model shows what? So we're running out of time, so we're gonna go faster. Even if you don't get in the response, just listen to my explanation, that's fine. So deployment model shows how the functionality is physically distributed to processing nodes. So it shows the deployment diagram shows the nodes as the processors and relationships as the network. So you design deployment model to consider which nodes are involved, what connections are there. Is it wireless? Is it high-speed fiber? Is it Ethernet? What are the characteristics of the connections? What's the bandwidth? Is it a high-speed connection, or is it unreliable wireless connection? And other redundant processing capabilities, all these platform information. So deployment model shows two ways correct how subsystems are assigned to processing nodes, how classes are mapped to subsystems. This is not the deployment model. This is part of the design model. How use cases are mapped to subsystems. Use cases are not mapped to subsystems. Classes are. So you may collect, say, all the user interface classes into a single user interface subsystem. So this subsystem may participate in many use cases. Any use case that involves a user interface may need the subsystem, but so use cases are not mapped to subsystems. Classes are. classes that realize a use case. That's not correct. That's the design model. So classes that are active, that's the active classes. That's not. So the deployment model shows the subsystems level, not class level mapping. So subsystems mapped to processing nodes. So a component in the implementation model can represent source code, runtime library, a manual, or all of the above. It's all of the above. So a component model can include obviously executable and file, but it can also be a library, static or dynamic, a database table, or a document like a manual. So it's a very generic term. These are stereotypes. Remember, these angular brackets, they are annotations to the class diagram to represent special meaning. The purpose of software testing is to first prove that there's no bugs in it. Second, show it's well structured, good architecture, good quality, or try to find defects. Five is correct. Show the tries to find the differences between the specified behavior and observed behavior, difference between validation and verification. I hope you have known that. The goal is to find defects. So you cannot show that software has no bugs in it. It's not possible. So 4, show the software product is of good quality. That's hard to show. So that's a very perhaps you test it for 3 months. You found many bugs so far, but how do you say it's of good quality or not? It's really not measured by testing. Testing helps you find bugs, but quality is measured by quality characteristics like all the design goals, right? Dependability, reliability, all the entities. That's not easy to measure, and not measured by testing. It's measured by some other means. So source code of a component is required to do which type of testing. This is relatively easy. It should be white box and regression testing. That is, it's obvious that white box testing needs source code. Black box testing doesn't need source code, but regression tests can be white box or black box. So it may need source code if it's white box testing. Retesting. These regression tests are testing old functionalities. You're rerunning test cases that have passed before after you've done some new development to show that the new things haven't broken the old functionality. So basis path testing ensures that you have tested at least So the answer is 3. Tested all the statements. So basic path testing. So it does more than testing all the statements, but it certainly tests all the statements at least. That's the testing the outcome of all conditions in the program. Let me see. Testing the outcome of all 4 conditions. This is a little vague. So it should test all the possible branching conditions, but the outcome of all conditions. So I think it's ill-phrased, this question. So so it certainly tests both branches for all if-then-else conditions. So I think it's not very clear question. So 2 of all the ways of executing the loops in a program. That's not correct, because if you do that, it takes you thousands of years, remember? So basic path testing really tests a piece of sequential code, and perhaps you have a loop. You have a for loop outside of this this block of code, and you for it for say 1,000 times. So if you test all the possible loop paths, it'll take you 2 to the 1,000 number of paths. That's obviously not feasible. But basic path testing really tests only 2 paths. See the difference there? Ways of executing the loops, that's tested in the loop testing. We discussed this before. You test the minimum loop index and maximum index, and in the middle, etc. So that's the reason, because you cannot test all possible ways. You must pick and choose the boundary. All the statements, that's correct. All data structures, data structure testing is done by data flow testing. So testing every statement in the program guarantees that all defects will be found. No way. So that's the example. This guy, by testing all the statements, you can take this right branch. This covers all the statements, but it's not enough, because for this guy, if you take the left branch, it causes a division by 0 error. Well, if you take the right branch, it doesn't have the error. So if you only test the right branch, you cover all the 4 statements, but you still have a bug you haven't discovered. Therefore, you need to cover all the paths. So, number of independent paths in the program can be determined by counting the number of regions, edges, nodes, loops. regions, not the loops. That's just not correct. So edges and nodes, so there's cyclomatic complexity can be determined by number of regions or number of edges minus number of nodes plus 2 or number of simple predicate nodes. Right? Simple predicate means that if you have A and B, that counts as 2 simple predicate nodes. You need to break up the compound predicate nodes into simple predicate nodes plus 1. So this question here, 1 is correct. If you had a choice as edges and nodes, that would be correct. But here, this edges or nodes, that's not correct. What is the this question has a figure on it. Right here. So this is an easy one. So I just so the actual question will be given in the form of this program, and then you need to draw the flow graph yourself. So suppose this is drawn already, and obviously you have 5 regions. Okay, so yeah, when testing a nested loop, we initially test the inner loop while holding the outer loop at its what value. This is the loop testing. At its minimum value. So simple loops, you do these things, skip it 1 pass, 2 pass, etc. So for nested loops, you hold the outer loops at the minimum iteration values. That is, you have outer for loop I equals 0 to 99, inner for loop j from 0 to 50. Then you hold the I at 0 when you're testing the j loop. So this is really a convention to simplify the inner loop testing, and perhaps the outer loop index is used in the inner loop in some way, but holding it at the minimum value, the inner loop is somehow simplified. But obviously, it's not sufficient. You need perhaps the bug happens when the outer loop is at the middle or maximum value, but you need to pick and choose the minimum value as a high probability of finding bugs. You don't guarantee anything. So in black box testing, we use test case values as the boundaries of the equivalence classes because of what reason? Because errors are likely to occur there. So errors are more likely to occur at the boundaries than in the center. So why? Think of the perhaps a condition loop, right? You say I less than equal to 100. If you somehow mistype the less than equal to as the simple less than, then by using boundary testing, you test the value 100, you detect the error, right? But if you try the middle values, you won't detect this error. So the boundaries are the things that are likely to go wrong. That's why you need to test the boundary values. black box testing are used for doing Yeah, integration testing is correct. So integration testing is first incremental integration and possible design goals. Hold on, let me see. Yeah, it's for integration testing. All the others, like the inflow testing, loop testing, condition testing, these are different types of white box testing, if you recall, right? So white box testing consists of basis path testing and condition testing, loop testing, and data flow testing. So unit testing is typically done with white box testing. So it's not a type of white box testing. That is, you may a representative testing strategy is that unit testing is done with white box testing done by the component engineer who developed the code. Integration testing can be done with white box or black box testing. So system testing is always done by black box testing. Acceptance testing is black box. So therefore, integration testing is the only type of testing among the 5 here that's possible for black box testing. All the others, you need the source code for white box testing. Consider a program, the scheduling of rooms for school. One of the required inputs is the day of the week, which is the Sunday, Monday, etc. In doing black box testing of the program for the input day of the week, how many test values would you use? So you should use 8. So you treat it as a set and test every element of the set, and then you test one value outside of the set. If you recall the black box testing for sets, so you may treat it as perhaps a range and pick in the middle and in the boundaries. Even if you treat it as a range, it still has 5 values, right? So you have a middle one, you have one less than the minimum, one greater than minimum. So 3 is never correct. So this question here, perhaps 5 and 8 should be both okay, but 8 should be better because it's a small set. It's only 7. If you have a million, you should treat it as a range. But if you have 7, you treat it as a set. The one is not a legal. So remember, in the set testing, you're testing all the elements of the set and something outside of the set. You can pass it in the garbage, like pass in, 5 instead of a Monday, Wednesday, etc. So integration testing, we focus on focus on the interaction among the components. So yeah. So focus verifies that component subsystems interact correctly. So someone chose 3 user requirements. That's part of the acceptance testing, not the integration testing. What statement is true about system testing and acceptance testing? Two is correct. System testing is done by the developers. Acceptance testing is done by the client. So system testing is should be done before the acceptance testing. Acceptance testing happens at the very end. After it's done, the whole contract is finished. So 5, none of the above. That's not correct. So poor quality software results from poor project planning, failure to understand requirements, inappropriate software development process, inadequate software testing. Yes, all of the above. So I think I may have said something wrong about the black box testing. Let me grab the testing slides on testing for ranges. If input is a range, oh right, here it says it's a range, then it's use the minimum, maximum, and something just above, just below. So it's 6, not 5. So I said something wrong for the yeah. So if you don't mind, I think I'll drag on for 10 more minutes, unless someone kicks me out. So, which of the following is an example of an external attribute of software quality? Portability is one example because so remember the difference between the external quality and internal metrics. So external is the maintainability, reliability, all the entities. Internal is the measurable things like number of parameters, number of lines of code, and cyclomatic complexity. So we're trying to predict the external design goals from the internal metrics by this is part of the estimation process. So all the others, like lines of code, fan-in, cyclomatic complexity, these are internal attributes, not external. Cyclomatic complexity of a program can tell us something about which of the following external attributes of software quality. It is 3. So cyclomatic complexity can tell us about portability, and it's not shown here. I thought it's shown somewhere. Maintainability. So, well, you can use the intuition, right? What does it mean for a piece of software to have high cyclomatic complexity? It means that it's highly complex control flow, many if-then else's. So if you do then portability is slow, because if you need to modify it and perhaps port it to another platform, you need to understand it. It's very hard to understand. And safety may be low because it's easy to have a bug hidden inside the many layers of control flow, right? So it's you should limit the cyclomatic complexity of your software modules to a low number to keep the complexity low. But usability and learnability, these are really user interface elements. They're not related to cyclomatic complexity. Software configuration management, the baseline is so a point above, after which changing artifact requires approval. 2 is correct. So after a milestone point, then the any changes must be formalized, go through a review process. You need to do a checkout. So someone chose 3. Division between the construction and transition phase. That's not correct. After every major milestone, you need to have a baseline, not just between these 2 phases. Point at which you start to implement. That's not correct. You start to implement. After you start to implement, you may have many baselines, maybe 4, 5, 6 baselines, until you get to the final deliverable. Indication if the project is on schedule or not. That's measured by the milestones, but a baseline is this concrete piece of software you have developed at the end of a milestone. So milestone is a time point, baseline is a piece of software, a concrete system that you can run. In software project management, estimating is made more difficult by what? So estimating means that you estimate the time and the resources needed for a particular subsystem or module. It's all of the above. So estimating is based on experience, courage, historical data. So vague requirements. I guess it's not explicit on the slides. It's in the notes. So incomplete requirements and others, lack of historical data, lack of prior development experience. So which of the following cannot be shown in the Gantt chart? Four is shown in the PERT chart. If you recall, PERT chart shows the critical path. So task dependencies are shown, time estimates, resource assignments, progress. They're all shown in the Gantt chart. Okay, so good luck in your exam. I'll be in my office most of the time. If you drop by during daytime, you can perhaps catch me if you have questions. So see you later.